Hello, geologists! To start off, we're going to talk about Table Mountain, where it's located and why it's a cool place to talk about.
We will get to the other bullet points later.
This is Table Mountain. Table Mountain is located in South Africa. Well, specifically an area called Cape Town, which is located right about here.
The top of this 3-kilometer plateau is flat like a table, hence the name Table Mountain. This is what makes it unique.
Now, Table Mountain is the biggest flat-top mountain in the world, reaching an elevation of 3,558 feet, which in turn makes it a natural phenomenon. In fact, it is the only natural feature on our planet that has a constellation named after it.
What also attracts attention is the tablecloth of clouds that forms on top of it, as you can see here. Additionally, Table Mountain was formed over 600 million years ago, 6 times older than the Himalayas, and one of the oldest mountains in the world.
That's older than me! Alright, back to the bullet points. Let's talk a little bit about background and formation. Well, we're going to look back about 300 million years ago. Now, this was during an ice age. So, during this ice age, there were these large ice sheets that flattened the layers of the sandstone, and this created the flat surface that we know today as Table Mountain, or tabletop.
Not only is it a cool-looking mountain, but it also has some unique caves. It all started with the shifts in the tectonic plates that occurred between the South America and African plate boundaries. The shifting of the plates led to cracks in the sandstone of the Table Mountain.
Water then eroded away at the cracks, forming caves, and as the sea level dropped, the caves finally became visible. Alright, feeding into our last topic, we should talk about what the caves are made of, and this leads into the composition and the deposition of Table Mountain.
The mountain is primarily made out of sandstone, shale, and granite. We all know by now that the composition of rocks will always tell an interesting background story.
This begins about 540 million years ago, when the Earth was covered with volcanoes. Magma flowed upward from deep within the Earth's core and pushed up into the tiny cracks within the layer of shale. When magma cools, it becomes granite.
Further tectonic shifts, ice ages, rising and falling sea levels eventually flattened out the surface of the rock. That allowed for layers of sandstone to settle on top of it.
This is also seen in Seaport, where we can see the prominent erosion of the rocks.
Alright, let's talk a little bit more about the depositional environment in which these rocks were formed. As we can see, there are many different layers that exist within Table Mountain. However, we are just going to discuss the 3 main environments in which sandstone, granite, and shale were formed.
Looking at the depositional map, we can see that the main part of Table Mountain is composed of sandstone. On the far side of Devil's Peak, we see peninsula shale, as well as a small portion in the center. Finally, we see 2 types of granite, North and South Peninsula, surrounding the outer edges of Table Mountain. But how did it get there? Well, 800 million years ago, deep water collected ocean sediments, which formed a shale shelf. 600 million years ago, magma intruded the core of the shelf, creating a granite inner core. 450 million years ago, layers of sandstone were deposited on top of the granite and shale, creating what we know now as the Cape supergroup. And finally, around 300 million years ago, the Ice Age deposited our final layer of sandstone sediment. Thanks for watching, and we hope you enjoyed this trip to Table Mountain.
Or, as they say in Afrikaans, baie dankie dat julle ons presentasie gesien het.
Bye!